Right. So as I was saying, David, there's a certain kind of source code that we have. We have got to jot that down in our particular text editor, right, or a terminal. Okay. Once you're done with that, you have to save the file with the particular extension called as .java. Okay. And for the sake of flexibility and ease, what we can do is we can make a separate folder for the programs and save them over there, right? All right. All right. Now we come to the part of compiling the program. How do we do it? Okay, so we go to our terminal window. Okay, we route it to a particular folder where we have saved the file. Okay, and then there's a particular command for which you have to execute in order to compile the source code. The command is javac and space and the file name. In our case, it would be javac space hello.java. Okay, during the compilation, Java adds a file to the disk called a file name.class, or in this case, hello.class, which is the actual bytecode. Sorry, come again? No. Yeah, but this converts into a particular file that has the .class extension. This converts that particular hello.java file into a new file called as hello.class. Okay, which is something called as a bytecode. It is the machine understandable code which it converted from a normal English language to the machine code. Okay, so that stage is complete. Compiling phase is completed. Now moving ahead, we are going to make it run. We are going to actually make it interpret by the machine. To run your Java program, type in the command java and the file name without any extension. In our case, it would be java and hello. If you do that, the machine code will run, and on the terminal window, you'll be able to see a message, hello world, which is the objective of the source code which you have written before in this program. That's the purpose of the program. Okay, so this was just a rough phases of how you go ahead to write a program. There are possibilities sometimes that you might have typed in something wrong, something syntactically wrong or grammatically wrong. Okay, so what we have something called as syntax errors. These errors are usually typing errors. Okay, and the most common of them are misspelling or forgetting to write a semicolon at the end of a statement. Some common programming errors. For example, we need to have public static void main, but by mistake, instead of writing static, I ended up writing static t. Right, and this was supposed to end with a semicolon, but I forgot the semicolon. Right, so these are some of the syntax errors. And when I run the program, I get the messages on the screen saying that, boss, you have typed something wrong. I was expecting something else. I've got something else. Okay. Runtime errors. These errors will not be displayed until you run your program. Even programs that compile successfully may display the wrong answers if the programmer has not thought through the logical processes and the structures of the program. For example, you want your program to print 100 strings of the hello world, but it only printed 99. Your program gets an input from the user, but the user inputted a character, and so your program crashes or terminates. So these are the kind of errors that will be only detected when the program is running. And unlike the syntax errors which you come to know while compiling it. And that's pretty much the first PDF. A very basic level PDF. Do you have any questions so far from this particular PDF that we looked up? You good enough? Alright, let me jump onto another PDF. This is the place where we explore a bit more of Java. Okay, so just a historical background. Java was created in 1991 by Mr. James Gosling of Sun Microsystems, initially called as Oak, and name of the tree outside Gosling's window. Its name was changed to Java because the name Oak was already taken by someone else as a trademarked name. A bit more of history. The original motivation Java, the need for platform independent language that could be embedded in various consumer electronic products like, toasters or refrigerators. At the same time, the World Wide Web and the internet were gaining quite popularity, and Mr. Gosling realized that Java could be used for internet programming as well. The platform independent language and the platform independent programs perfectly fit the need of the internet at the time, where programs can be downloaded to different type of browsers that are called as applets, which is still a very popular way of using Java. Applet are small Java programs and it runs on your browser. We'll see about them eventually. But these are some motivation factors because of which Java was born. These were some motivating features because of which Mr. Gosling thought that okay, I have a problem scenario and these are the things that I have to cater to. When we talk of Java, okay, we normally think Java from three perspectives: either a programming language, a developer environment, or a runtime environment. When I say that Java is a programming language, what I mean is, as a programming language, Java can create all kinds of applications, particularly desktop applications such as word processing applications via Java SE, enterprise applications such as inventory management systems via Java EE Enterprise Edition, mobile applications that run on mobile devices such as phones and tablets via Java ME. Sorry about that. Internet applications that can run inside browsers, so-called applets, and even the most tiny applications that run on credit card-like devices, called as Java Card. When I see Java from a development environment perspective, what it means is Java technology provides you with a large suite of tools, namely the compiler, Java C, or the Java compiler, an interpreter, Java, that is a Java runtime interpreter, a document generator called as Java doc, and a set of libraries, star.jar files. JDK, that is the Java development kit, provides all of the above. And there are many other editors, namely Eclipse, NetBeans, or IntelliJ IDEA, which help you achieve them. IntelliJ IDEA, that is also another, it's an editor. The way you have Eclipse and NetBeans, IntelliJ is also an editor. Okay. Now, Java technology as a runtime environment. What does that mean? That means Java applications run over Java runtime environment, the JRE. JRE is also called as the Java Virtual Machine. Examples: JRE over which a desktop application runs, java.exe. JRE built in a browser, or a JRE that comes bundled up with a server, or JRE that is running on mobile devices. It is these JREs of all these diverse set of platforms that provides the common runtime environment for Java programs, namely write once, run everywhere. Yes, the JDK. When you install Java, you get JDK, which is meant for development. But if you have applications that need Java, not for making purposes, but just as an extension, there is a JRE, runtime environment, which suppose your Java applications running on your system, namely a mobile device or a desktop application or on a server. Right? You with me so far? Absolutely. Cool. Should I go ahead? Cool. On an overview level, Java platform is divided into three editions: the Micro Edition, the Standard Edition, and the Enterprise Edition. Micro Edition caters to the Java technology for enabled devices, like mobile phones. Then standard edition is a very general way of looking at it, which is particularly meant for your desktop applications. And the server level applications, the server groups are catered by the enterprise edition. Yes, it's particularly for the mobiles. But don't confuse this with Android. Android still uses SE, Java SE. Does not use the Java micro edition. They are two different things. On a broader perspective, you have the Java EE, that is the Java Enterprise Edition, then your Standard Edition, which we are going to focus on, okay, and then you have those tiny devices running the JVM for some Java enabled applications, as you can see on the pictures. Okay, so I mean it can be visualized from three perspectives again: a Java application or a JVM and the operating system. All of these things need Java. The applications that you make need the Java running in the background so that you're able to make it. The Java virtual machine is the one responsible for running applications without you actually installing the JDK, the development kit. Okay. Sorry? Sure, please. Hello. Yeah. Hello. Yes, I can. Yes, go ahead. No problem. Are you done? Are you done with that? Okay, no problem. Okay, so what I was trying to explain here is one of the keen features of Java. Let me give you an example. I'm sure you must be aware of C and C++, right? Yeah. So, I mean, the way it works is, let's say you have Windows machine. You made a C program, C++ program, you compiled it, you got the .class file, okay? Let's say you take this .class file from Windows machine to a, let's say, Linux machine. Okay, now this is a compiled version. Now you're going to run it. When you try to run it on a different machine, it does not run. Okay, it does not run. Hello? Why is that? It's made that way. The interpreter that's responsible for running the program is made that way. Whereas, if you talk of Java, okay, it converts, let's say again, the same scenario, Windows machine, the Java program is executed, okay, we get the .class file. In this case, if the .class file is taken to another environment, let's say a Linux environment, and there if you try to run the program through the interpreter, it does run. It actually runs. It's because of this particular JVM, the Java Virtual Machine. It's made in such a way that it has those components that detects this bytecode and runs it immaterial of the source where it was created. This is one of the heaviest benefit Java has as compared to other programming languages. And I'm sure you must be aware of this by now. The phases of how we go ahead. We have the editor first. We write the hello world.java. Then we take it through the Java compiler. Okay, only one time. We get the .class file. And then we can take this .class file or the bytecode and run it as many times as you want through the Java interpreter. So, I mean, the way we go. As per requirement, you can do it one time, two times, but when you do that, you don't need to compile it again. You don't need to compile it again. You just take the .class file and place it anywhere, any environment. It will be good enough to run. Okay. .class file, which is called as the bytecode. Exactly. Okay, so the first stage will be writing the program, and the tools will be our text editor, and we have to save the file with a .java extension. Further on, we have to compile the program. We use a Java compiler, right? And because of which we get the particular .class file, which is also called as the Java bytecode. Alright, and as you go ahead, we have to run the program. We have a Java interpreter, because of which we see the actual program output. Yep, and